everyone. So today we are completing section 1.4. So we are still on the topic of quadratic equations. So let's get started. Section 1.4.3 is all about completing the square. The first thing here is talks about completing the square method, and these are just the steps. We'll talk about it in a couple of examples. Right. So first of all, before we learn about completing the square method, we have to learn about completing the square. So let's focus on step 3. Okay, so step 3, to complete the square, we're going to add okay, so this has to do with an equation. So I'll just talk about completing the square. So if for an example I have x squared plus 12x plus n, right? We want to solve for n, right? So how do we do that? When you're completing the square, what you're going to do, so keep in mind this is in the form ax squared plus bx plus c. All right, so essentially what we're looking for is we're looking for what c is. Okay, so we're taking this b. Okay, so in this case, b is equal to 12. And what we're going to do, we're going to do b divided by 2. Okay, so we want 12 divided by 2. Right, and then we're going to square it. So b over 2 quantity squared. So this is going to be 12 over 2 quantity squared. When I solve for that, this becomes 6 squared, and this is 36. Right, so we found that n is equal to 36. So over here we have x squared plus 12x plus 36. All right. So how do we know if this is correct? If we are correct, we should be left with a perfect square trinomial. So if we factor this, we'll get x plus 6 quantity squared. And if you want to check it, we can either FOIL it or we can use the perfect square trinomial formula. And so actually, since I want to emphasize the perfect square trinomial formula because I think it's a good formula to know, let's do it. So this is just x squared, and this is plus, okay, we're going to use the plus because the plus is right here. And then it's going to be 2 times x times 6 plus 6 squared. So this is x squared plus 12x, plus 36, right? These two match, right? So therefore this, okay, that's not our answer. This, we did it right because we're able to turn this into a perfect square trinomial. One thing I want to note is over here, so how do we always know what this would be? This, for any given case, it should be x plus b over 2 quantity squared. As you can see, the b over 2 was 12 over 2, that's 6. And look over here, it's 6. Okay, you can also look like at x plus 7 quantity squared. We know that's x squared plus 14, x plus 49. Okay, even if we wanted to check, we'd be 14 divided by 2 quantity squared. Okay, that is 7 squared, so 49. Right, and as you can see, that's it. Right, so now that's completing the square. So now let's complete the square when we're given an equation. Okay, so we want to solve x squared minus 3x, or minus 3 is equal to negative 10x. Right, and we're going to complete the square and use the square root property. So let's look at the steps above. So step 1, it says divide both sides by a so we can make the leading coefficient 1. In this case, our leading coefficient is already 1. So step 1 is done. Step 2, we want to isolate the variable terms to one side of the equation. So the variable terms, so this is a quadratic equation in terms of x, right? So we want to isolate x and the negative 10x. I'm actually going to, so some of you might want to subtract this x over, the x squared over. I'm actually going to add 10x and then add the 3 to both sides because I want the leading coefficient to be positive. So if I do that, I get x squared plus 10x is equal to positive 3. Right? I added 3 to both sides, and I also added 10x to both sides. Right? Now that we've isolated, we're going to complete the square. Right? So what we're going to do is we're completing the square on this. So so step 3, okay, essentially what you're doing, okay, you don't need to write this particular thing, but you want to find this n. Right? So how are we going to do that? We are going to add b over 2 quantity squares to both sides of the equation. The reason why we're going to add it to both sides is because this is an equation, so we want to keep this balanced. If I just added it to the left-hand side, then if we compare this one to over here, it's not the same. So first of all, what is b over 2 quantity squared? It is 10 over 2 quantity squared, 5 squared, 25. Right, so I have x squared plus 10x plus 25. Right, so as you can see, if I don't add 25 over here, right, then this, if I don't add it, if I try to go back, all right, it would not be the same. Okay, so essentially what you're doing, so they said add it to both sides, right, but essentially what you're doing is plus 25 minus 25 is equal to 3. Okay, so as you can see, we're adding 0 because 25 minus 25 is 0, and if we do that, we're still left with x squared plus 10x is equal to 3. Right, but that's why we add to both sides. Okay, because if I add 25 to both sides, that's still, it's what we'll get. Okay. So now, continuing on with step 3, this is step 3 part B, we want to factor the resulting perfect square trinomial. So x squared plus 10x plus 25, this factors into x plus 5 quantity squared. Alrighty, so if you want to check, okay, we can quickly do a little check. So this is x squared plus 2 times x plus times 5 plus 5 squared. This is x squared plus 10x plus 25. Right, so this is the exact same as the above, so we know that we completed the square correctly. Now we're going to do step 4, and we're going to apply the square root property and solve for x. Right, so remember the square root property, if I have like this big, if one term is like it's just completely squared, okay, we can use the square root property, so this becomes x plus 5 is equal to plus or minus the square root of 28. Okay, so then we have x is equal to minus 5 plus or minus the square root of 28. Right, the square root of 28 can be simplified. Right, there's a perfect square that can go in there, which is 4. Okay, so I have x is equal to negative 5 plus or minus 2 square root of 7. Right, before I say this is done, I do have to check, is the square root of 7, is that as simple as it can get? The answer is yes, because 7 is a prime number. Right, so we know no perfect square goes in it besides 1, but like we said before, 1's kind of pointless, okay, because it doesn't change anything. Right, so this is our solution. Right, you can also write it in the set, so like this. Okay, either way, that's it. And then we'll talk about these in-class problems on Wednesday. One thing I do want to emphasize, I really want you guys to look at this number 3, which is ax squared plus bx plus c is equal to 0. All right, that'll give us a very interesting result, but we'll talk about that more in class. Right. So now that we know how to complete the square, okay, we can talk about the quadratic equation, okay, by using the quadratic formula. Hint, hint. Number 3 will help you. Okay, so what is the quadratic formula? The quadratic formula actually derives from completing the square, but I want to derive it in class, so we'll talk about it more. But So instead of deriving it and then introducing it, I'm just going to introduce it and we'll derive it later. So what is the quadratic formula? It says for a quadratic equation of the form ax squared plus bx plus c is equal to 0. A does not equal 0, remember, because if it does equal 0, then we're just left with a linear equation. Then we are given the solutions x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I know most of you are probably familiar with that. Okay, so let's go ahead and implement it. So for the first example, okay, we want to solve the equation by applying the quadratic formula. We're given x times x minus 6 is equal to 3. Alrighty, so when we use the quadratic formula, okay, before we use it, we have to make it look like ax squared plus bx plus c is equal to 0, right? This looks nothing like it. So what am I going to do? I'm going to distribute x on both sides, or I'm going to distribute this x. So that's x squared minus 6x is equal to 3. Right, we're so close, but remember we want this to equal 0. So I'm just going to subtract 3 to both sides, and I'm left with x squared minus 6x minus 3 is equal to 0. Okay, so let's apply the formula. So what is A? A is 1, B is negative 6, and C is negative 3. Right? Keep in mind these are all pluses. Right? So this can actually be rewritten as x squared plus negative 6x plus a negative 3. Right? So now let's apply the formula. We are given x is equal to negative b plus or minus the square root of b squared, b squared minus 4ac all over 2a. I do suggest when it comes to memorizing formulas, if you're not familiar with this one, just write the general formula over and over before you do a problem, and trust me, it will get engraved in your head. Okay, so now let's plug in what we know. What is b? B is negative 6. This is plus or minus. B squared is negative, so this is negative 6 quantity squared. 4ac. Right? And I'm going to make sure everything is under my square root. This is all over 2 times 1. Okay, so it's negative times a negative 6. That's pretty much negative 1 times negative 6. That's positive 6. Plus or minus. Negative 6 quantity squared, that is 36. And then negative 4 times 1 times negative 3, that's positive 12. All over 2. Okay, so I'm left with 6 plus or minus, and then 36 plus 12, that's 48, all over 2. Okay. When I solve for this, 48 can be reduced, right? 48 is 16 times 3. Right, so this becomes 6 plus or minus 4 square root of 3 all over 2. They all have a 2 in common, so I'm going to factor out that 2. Then I'm left with 3 plus or minus 2 square root of 3 all over 2. These reduce to 1, so we are left with 3 plus or minus 2 square root of 3. So if you plug this back into our original equation, you should get 3, right? Or you can use this one, equals to 0, and if you do all that, then it equals to 0. Remember, the only way you can use this one is if you double check to see if it's equivalent to these two, right? But this is our solution. One thing about the quadratic equation, so I notice a lot of people, they really like using this, and they start to rely on it. However, look at how long this process is. Even if I use the quadratic equation for, let's say, like x squared plus ax plus 12, right? For factoring, this is actually x plus 6 times x plus 2, right? See how simple that was? We use the zero product property, blah, blah, blah. We'll get x is equal to -6 and -2, right? That's really, really fast. But if I say x is equal to -8 plus or minus the square root of x squared minus 4 times 1 times 12 all over 2 times 1. Right, solving this is just going to be so tedious. So usually for the quadratic formula, it is my last resort. Right, so let's do another problem. Okay, so this one's a little more complicated, but that's fine. Okay, we are given 3 over 10 x squared minus 2 over 5x plus 7 over 10 is equal to 0. Alrighty. You guys could, so there's two options. You could just look at it as is, and you can say A is equal to 3/10, B is equal to -2/5, and C is equal to 7/10. Okay, but I don't know about you, but fractions are gross. And when you're already having to deal with such a complex formula, okay, it's just gonna become a big headache dealing with all these fractions as well. So what I would suggest doing is, I know I'm gonna look at for the LCD. So there's a 10, a 5, and a 10. So what am I gonna do? I am going to multiply both sides of my equation by 10. Okay, and when I do that, so we're ignoring this. When I do that, I'm left with 3x squared minus 10x. No, geez. Oh, my brain stopped working all of a sudden. This is minus 4x plus 7 is equal to, and 0 times 10, that's 0. Right, so this still equals 0. Okay, we're just rewriting it to make it look a little nicer. Right. Okay, so 10 minus. Okay, sorry guys, I second guessed myself. Right, so now that we're dealing with whole numbers, this looks a lot more doable than up here, right? So A, I'm going to say is 3, B is -4, and C is 7. So much better. Okay, so let's apply the formula. I just did this one to show you, give you guys an example of this is what you should do. Write the formula first, and then plug everything in. Okay, I'm not going to do it for this second one. Actually, what the hey, I'll go ahead and do it. Okay, so this is -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug things in. So -4 plus or minus -4 quantity squared minus 4 times 3 times 7 all over 2 times 3. Okay, so this is 4 plus or minus 16. And then -4 times 3 times 7, so this is -12 times 7, so this is -84 all over 6. Okay, 16 minus 84, okay, so this is just 84 minus 16, so what is that? That's 68. Okay, but remember we want to keep the sign with the biggest number. The biggest number is 84 and it's attached to a negative all over 6. Okay. Trying to think. I think this, so okay, so there's a negative under our square root. What does that mean? We're going to take out the negative, so it's 68, and this is over 6. Okay, I think, so the biggest square that I'm seeing is for 68 is 4, so let's go ahead and pull that out. Okay, so this is 4 times, and this is 17. Okay, all over 6. When I do that, I get 4 plus or minus I2, oops, rewrite that more properly. I'll call this 2I square root of 17 all over 6. Okay, they all have a 2 in common, so this becomes, so I'm going to factor out a 2 on the top, so this becomes this. Oops, this is 2. Okay, and this becomes 2 times 3. Okay, the 2's can cancel, so this is 2 plus or minus I square root of 17 all over 3. Alrighty, I'm looking at the square root, alright, and it's as simple as it can get because 17 is a prime number. Alright, so that's our answer. Okay, so this is applying the quadratic formula. Okay, so a summary, so the methods you can use to solve a quadratic equation, remember a quadratic equation is ax squared plus bx plus c is equal to 0. Right, you can either apply the zero product property, you can complete the square and then apply the square root property, or you can apply the quadratic formula. Again, I really want to iterate quadratic formula. That would be my last resort. Right? So now that we know all this, let's talk about the discriminant. So what is a discriminant? A discriminant of a quadratic equation ax squared plus bx plus c equals 0, a not equal to 0, is the quantity b squared minus 4ac. Okay, and if you notice, if we look at this, what is b squared minus 4ac? It's the radicand right here. Right? It's the value underneath the square root of our quadratic formula. Okay, so let's do some examples. So I'm getting ahead of myself. So what does the discriminant tell us? This discriminant, okay, tells us, like we can use it to determine the number and type of solutions to a quadratic equation. So looking at our table, if b squared minus 4ac, if that is negative or less than 0, we get 2 non-real solutions. If the discriminant equals 0, we get 1 real solution. Okay, if b squared minus 4ac is positive or greater than 0, we get 2 real solutions. All right, so let's just do some examples. Okay, so for the first example, we're given 2x squared minus 3x plus 5 is equal to 0. Okay, so a is 2, b is negative 3, and c is 5. Okay, so if we get b squared minus 4ac, okay, this is negative 3 quantity squared minus 4 times 2 times 5. When we do that, we get 9. And then this negative 4 times 2 times 5, that is negative 40. Okay, 9 minus 40, so 40 minus 9 is 31. The 40 is bigger and it has a negative. So our discriminant is negative 31. Negative 31 is definitely less than 0. So does that tell me? This tells me this is 2 non-real solutions. Okay, non-real is also the same as 2 imaginary. Okay, if you look over here, the examples I picked, they're all the same. So if we look at the results of a quadratic formula, then you'll see that it's plus or minus the square root of negative 31. And that should tell you, so if I have 3 plus or minus the square root of negative 31 over 4. Okay, if we simplify it as 3 plus or minus I square root of 31 over 4. Okay, so this is 3 plus I square root of 31 over 4 and 3 minus I square root of 31 over 4. Right, so 2 non-real solutions. All right, now let's look at x squared plus 6x plus 9 is equal to 0. Okay, so for b squared minus 4, let's establish our variables first. A is 1, b is 6, c is 9. Okay, so for b squared minus 4ac, this is 6 squared minus 4 times 1 times 9. Okay, 6 times 6, or 6 squared is 36. Negative 4 times 1 times 9, that's also 36. This is equal to 0. Okay, so what does it mean when the discriminant equals 0? That means we get 1 real solution. Alright, so let's look at the results of the quadratic formula. We get x is equal to 6 plus or minus the square root of 0 over 2. Right? Makes sense because what is the square root of 0? It's 0 because 0 squared is equal to 0. Therefore, right, so I get 6 plus or minus 0 over 2. Okay, so this is just, plus or minus any, like if you're adding or subtracting, nothing stays the same. Okay, get 3. So one solution. Right. Last problem for today. Okay. We are given 2x squared plus 7x minus 1 is equal to 0. Right, so a is equal to 2, b is equal to 7, c is equal to negative 1. Right, so for b squared minus 4ac, this is 7 squared minus 4 times 2 times negative 1. Right, 7 squared is 49. Negative 4 times 2 times negative 1, that is a positive 8. Right? So 49 plus 8, that is 57, which is definitely positive. So what does that tell us? That tells us this is 2 real solutions. Okay, so let's look at the quadratic formula. We get x is equal to negative 7 plus or minus the square root of 57 over 4. Right, so yeah, we don't really have to do anything. It's negative 7 plus the square root of 57 over 4, and negative 7 minus the square root of 57 over 4. Alrighty. So even looking at the quadratic equation, what is this? When we just do the discriminant, okay, we get negative 68. Okay, and so you'll see we get 2 imaginary solutions. So that's one thing I wanted to point out. The discriminant, okay, 0, you get the just 0 under the square root. The negative 31, same thing under the square root, and then 57 is the same thing when you apply the quadratic formula. Ready? So that is it for today. We'll talk about the in-class problems. Okay, remember, try to look at the ax squared. Try to solve this. Alrighty, so you should actually try solving all the in-class problems beforehand, but I know not everyone's going to do that, so I just ask everyone, please at least just try this one. Alrighty, so that's it for now, and I'll see you guys on Wednesday. Bye!